Hey, good morning, guys. So today we are going to talk about something kind of completely new. Something called quadratic equations. Okay, so what we've been talking about, and we're gonna kind of bypass the do now, just because the lesson's gonna take some time today. These are what I circled. Those are called linear equations, right? Linear equations, as we noticed, will graph to make straight lines. So if I plot the points for x and y that make each of those equations true, it's going to give me a straight line. What we're going to see as a quadratic equation is going to have x raised to the second power. So one of the things we talked about the first day with linear equations was that in order for it to be a linear equation, x had to be raised to the first power. So if x is raised to the second power, it's not going to be linear anymore. It's going to be quadratic. Now, what exactly is that going to mean? Well, I don't know why the font looks a little weird here. It's going to be a U-shaped curve called a parabola, okay? So what does a U-shaped curve look like? Well, if that's my graph, right, and this, let's say, would be a linear equation, this would be a quadratic equation. It's actually going to look like a U. Sometimes that U opens downward. Sometimes we say it's upside down, but that's what it's going to look like. Now, how can we tell we have a quadratic function? And we're going to put this in our notes, right? We're going to get this in our notes. How do we know it's a quadratic function? This right here. Okay, the fact that x is raised to the second power. What else are we going to see? Well, we're going to see a coefficient of x squared. Okay. Sometimes we see a coefficient of x. Sometimes we see a constant. Okay, but really what's important? How do we tell something's a quadratic equation? And this is just an example of a quadratic equation. That's actually a pretty complicated one. We're not going to do anything that complicated this year. Maybe at the ends of the year, depending on how these things shake out in May or June, we may kind of revisit some of this stuff. But for now, we're going to be just working on very basic quadratic functions. What does it look like and how do we gather the points? Okay, so y is equal to x squared minus 3. So when we think about what values to assign for x, we're going to think about what we did for linear equations. In other words, if I say, well, what happens if x is 10? Well, 10 squared is 100 minus 3 is 97. 10 comma 97 is not going to fit on my graph. So we're going to do the same thing we did with linear equations, right? We're going to start with values that are pretty close to 0. So in other words, if this is going to be my 0, I'm going to try using 1, 2, and 3. And I'm going to try negative 1, negative 2, and negative 3. Now, one of the things we're going to notice about some quadratic equations is there's a lot of points that are not going to fit. Because think about it. We're squaring something. We're multiplying it by itself. Sometimes we're going to get some pretty big numbers here. Okay, not necessarily with this one per se, and that was by design, obviously. But some of these we're going to have some pretty big values. Couple things we need to be careful. Now, guys, I'll be honest, we're going to lean on the calculators for this, okay? Because otherwise it's going to be pretty time-consuming, and that's not to say that you have to, but the calculator will take care of this. Next year, you guys will have graphing calculators that will completely take care of it. But for right now, we're just going to put the expression in the calculator. You have to be careful to use parentheses, and we have to make sure we put the symbols like the negatives in the right place. Otherwise, it's not going to work. You're not going to get a U-shaped curve. So I'm going to have negative 3 in parentheses squared minus 3. Again, if those parentheses are not there, everything's going to be off. What's negative 3 squared? Well, negative 3 squared is positive 9, and 9 minus 3 is 6. So what you would put in your calculator is the entire expression. You're going to put in your calculator exactly like I just wrote there. Parentheses, negative 3, close parentheses, squared, and then minus 3, and it's going to give you 6. If the parentheses are not there, it's going to give you negative 12, which is not what we want. So you have to be really careful with the parentheses. We're going to do negative 2 squared minus 3. Well, negative 2 squared is negative 2 times negative 2, which is 4, and 4 minus 3 is 1. We've got negative 1 squared minus 3, which is 1 minus 3, which is negative 2. We've got 0 squared minus 3, which is 0 minus 3, which is negative 3. We've got 1 squared minus 3, which is 1 minus 3, which is negative 2. We've got 2 squared minus 3, which is 4 minus 3, which is 1. And we've got 3 squared minus 3, which is 9 minus 3, which is 6. So we look at this, and we say, I have the same values here and here, and the same values here and here, and the same values there and there. So I would ask the question, why do we think that? And that will not always be the case. But for this one, why do we think that's true? And someone raised their hand and said, well, if I square 3, or if I square negative 3, it's still the same, right? It's still positive 9. Because 3 squared, right? When you multiply a number by itself, when you square something, whether the number is positive or negative, the product's going to be positive. So negative 3 times negative 3 is 9, and so is 3 times 3. So that's why we have that symmetry. Now, in the middle, we have a point that is unique. In other words, I've got my 6 and my 6, my 1 and my 1, my negative 2 and my negative 2. I've got this point right here, right, where I've got that negative 3. This point is what's called our vertex. Now, that's not so important for today. We will revisit this topic. Let me write the word down here. But that's what's called our vertex. That's my unique point, and all the other points will be symmetrical around that point. So let's plot some points. So I'm going to plot, I usually like to try to plot my vertex first. So there's my 0, negative 3. Here's my 1, negative 2. There's my negative 1, negative 2. Here's my negative 2, 1. Here's my positive 2, 1. And here's my negative 3, 6. And here's my 3, 6. A couple things that are going to, so I have that U-shaped curve. Now, we're not going to use a ruler here, okay? We're going to try with our hands to make what we call a smooth curve. And I'm not saying my curve is the smoothest. It's a little hard to do here on the iPad, but that's what it would look like, okay? Are we still going to use arrows? Of course. We know that this is continuous. I know I can use 4 for x, and 5 for x, and 6 for x, and 10 for x, and get 10, 97 like I said before, okay? Now, why do we make it curved? Because if we tried, and this is kind of a little extension, but if I try a fractional point, like 1/2, it's not going to be exactly in the middle of negative 3 and negative 2. It's actually going to be below. So that's how mathematicians many thousands of years ago figured out how to make this curved as opposed to straight. Now what are we going to do? I'm going to label my equation. Where am I going to label it? I like to label it somewhere in the middle. All right, so what's our takeaway here, right? We should get a U-shaped curve. If you have something that looks like this, you made a mistake with your calculations with your calculator, so just be really careful. It should be perfectly symmetrical. You should have a half, you should have a perfectly symmetrical other half, and we should have a point down here called our vertex, right? That's the unique point on our table. All right, now, what's different about this one? Well, they put f of x. What is f of x? Well, that's just a fancy way of saying y, right? It means function of x. So just in case you see it, and again, I mentioned this before, usually when I do this lesson, I say, in the textbook, you're going to see such and such, but we don't have textbooks, and that's fine, but you will see this next year, and I don't want you to be confused seeing it for the first time. So y equals negative x squared plus 5. Again, f of x, you can just kind of filter that out, but just keep it in the back of your mind that that means the same as y. Now I've got negative x squared plus 5. So my procedure here is not really going to be any different, except for the fact that we have to be super careful with our parentheses. So here's what I mean. This is negative x squared, right? That really is the same as negative 1 times x squared. We are not multiplying our x by negative 1 and then squaring it. Negative x squared means I put my negative, I put my parentheses, and then negative 3 squared plus 5. Guys, if you do not do that again, everything else is going to be off. If you just say, well, the opposite of negative 3 is 3, and let me just do 3 squared, no. Order of operation says we do our exponents before our multiplication of negative 1. Not that we do multiplication and then go backwards and do exponents. Okay, and again, we're leaning on the calculator for this, but if you don't put it in exactly like I have it here, it's not going to work. So what's our calculator doing? Well, it's doing negative 3 squared, which is negative 3 times negative 3 is 9. Then it's multiplying by the negative to get negative 9, and negative 9 plus 5 is negative 4. And if your calculator didn't give you that, then you didn't put it in the right way. So now I've got negative 2 squared plus 5. So what's negative 2 squared? Well, it's 4, and then we multiply by the negative 1 to give negative 4, plus 5 is 1. Now we've got the opposite of negative 1 squared plus 5. So negative 1 squared is 1, times negative 1 is negative 1, plus 5 is positive 4. This one's an easy one, right? There's no such thing as negative 0, so it's just 0 squared is 0. The opposite of 0 is still 0, plus 5 is 5. Now we've got the opposite of 1 squared plus 5. So 1 squared is 1, times negative 1 is negative 1, plus 5 is positive 4. I've got the opposite of 2 squared plus 5. So 2 squared is 4, times that negative 1 is negative 4, plus 5 is 1. And the opposite of 3 squared plus 5. So 3 squared is 9, times negative 1 is negative 9, plus 5 is negative 4. So we've got that nice symmetry again. Right, I've got negative 4 and negative 4 for my negative 3 and 3x values. Then I've got 1, 1, 4, 4, and then I've got 5. I've got that unique value. Now, the unique value does not always occur when x is 0, as we'll see with the next one. But I've got that unique value called the vertex. So let's look what happens when we plot this one. So I'm going to plot 0, 5. I'm going to plot negative 1, 4, and 1, 4. I'm going to plot negative 2, 1, and 2, 1. I'm going to plot 3, negative 4, and negative 3, 4. So what do we notice, right? Well, to me it looks like it's upside down with reference to the original one. So what's different about this? Well, what's different about this is the negative. So anytime we have a negative coefficient of x squared, I don't care about x, I don't care about my constant, a negative coefficient of x squared, the parabola will open downward. It will appear to be upside down. All right, so I'm going to connect my points here. I'm going to connect my points here. And again, we are doing this without using a ruler, right? The mathematical vocabulary is we try to make a smooth curve. And I'm going to label it. I can label it really anywhere, right? I should technically label f of x. Not that it matters, right? Y is the same thing. So I'll label it f of x equals negative x squared plus 5. All right, so this one is going to be a little bit different, okay? Not that it's going to look different, but the table is going to definitely be a little bit different than the previous ones, right? So I'm going to do negative 3, negative 2, negative 1, 0, 1, and 2, and 3. Now, we have to be very, very careful with our parentheses. So x squared, if x is negative 3, is in parentheses negative 3 squared minus 4 parentheses negative 3. If you put in, and I'll write it a little bit bigger over here. If you put anything else other than this in your calculator, it is not going to give you the correct result, and your parabola is going to look all crooked. If you put a negative instead of a subtraction sign or vice versa, your calculator generally gives you some sort of error. So the 3, you're going to use a negative 3, but this is going to be a subtraction sign here. Now, yes, I know, in class, when people ask, is that a negative or a subtraction sign? My answer is they're the same thing. Really, they all mean negative. Your calculator, unfortunately, doesn't see it that way. Your calculator does differentiate between negative and subtraction just because of the algorithms and the way they're programmed, unfortunately. So let's go back to what we've got here. Negative 3 squared is 9. Negative 4 times negative 3 is positive 12, and 9 plus 12 is 21. Again, that's what your calculator's doing, okay? So if we need clarification on, why it's doing that, it's just an order of operations review we can do, but that's what your calculator is doing. And again, it's only going to give you that if you put it in exactly as is. So now I have parentheses negative 2 squared. Minus 4 times negative 2. So negative 2 squared is 4. Negative 4 times negative 2 is positive 8. 4 plus 8 is 12. Now I've got negative 1 squared minus 4 times negative 1. Well, negative 1 squared is 1. Negative 4 times negative 1 is positive 4, so 1 plus 4 is 5. I've got 0 squared minus 4 groups of 0, which will give us 0. I've got 1 squared minus 4 groups of 1, which is 1 minus 4, which is negative 3. I've got 2 squared minus 4 groups of 2, which is 4 minus 8, which is negative 4. And I've got 3 squared minus 4 times 3, which is 9 minus 12, which is negative 3. And we're going to step back and we're going to say, well, that looks kind of weird, right? It doesn't look exactly like the other ones that we've seen. The other ones had this nice symmetry, right? These same repeated y values. They were spaced out a certain amount. And it had this unique value called the vertex. Now, usually I have some kind of inquisitive mind that will look at this and say, but we still do, right? We just didn't take it far enough, right? I do see negative 3 and negative 3 next to x is 1 and x is 3. And maybe the next one would be 0 and then 5 and then 12, and it would work. And I say, okay, interesting, let's see. Why don't we start graphing and see what our graph would look like? Well, I can't fit negative 321. I can't fit negative 212. I can fit negative 1, 5. Right? So negative 1, 5 is here. And of course, I can fit the origin. And I can fit 1, negative 3. And I can fit 2, negative 4. And I can fit 3, negative 3. All right, well, that looks kind of like a hook, right? It looks like part of my parabola, but it looks incomplete. It looks unfinished. So what happens if my parabola is incomplete? Well, I just need some more x values. So let's see if what we originally kind of proposed or suggested actually would work. Well, what's going to happen if I use 4? Well, I get 16 minus 16 is equal to 0. Okay, so far so good. What happens if I use 5? I get 25 minus 20 is 5. That looks good. What happens if I use 6? 6 squared is 36 minus 24 is 12. Well, this is perfect. This is exactly what we wanted to happen. So I can plot those points, right? 4, 0, and 5, 5. And now we've got that perfect symmetry that we've come to expect from seeing enough of these things. So I'm going to do my best here to make a smooth curve. I'm going to use arrows at the end, as we always do, and I'm going to label my equation inside. All right, so I want to see how you guys do. So I'll get you kind of set up here. So we're going to start with these values. They're not all going to fit, and I'll tell you that right now. Okay? So this is your now try, so you can pause your video. You can make your table using your calculator and your graph. And then we'll come back and we'll go over it. So this is going to be kind of tricky. So maybe I should get you guys set up with the first one. So that's what our first one is going to look like. Okay? So if you do need some help, that's a little guide. So when we actually do this, we've got negative 3 squared is 9. So again, your calculator is doing this. I'm just kind of dictating what it's doing for you. Negative 3 squared is 9. 2 times 9 is 18 minus 5 is 13. We've got 2 times negative 2 squared. So negative 2 squared is 4 times 2 is 8 minus 5 is 3. I've got 2 times negative 1 squared. So negative 1 squared is 1 times 2 is 2 minus 5 is negative 3. I've got 2 times 0 squared, which is 0 squared is 0 times 2 is still 0, minus 5 is negative 5. We have 2 times 1 squared, so 1 squared is 1 times 2 is 2, minus 5 is negative 3. I've got 2 times 2 squared minus 5, so 2 squared is 4 times 2 is 8, minus 5 is 3. And I've got 2 times 3 squared minus 5, so 3 squared is 9 times 2 is 18 minus 5 is 13. And once again, we've got that really nice symmetry that we came to expect from the first two examples at least. 13, 13, 3, 3, negative 3, negative 3, and then we've got our vertex. So did we have a vertex for the last one, just to go back to it? Of course we did, except where was my vertex? My vertex was here. It just wasn't at 0 because we didn't have an x term before like we have here. So that's something I should have pointed out earlier. All right, let's do some graphing. So obviously negative 3, 13 is not going to fit in my graph, so I'm going to skip it. Negative 2, 3 will be here. Negative 1, negative 3 is down here. I get down to my vertex of 0, negative 5, and then 1, negative 3, and then 2, 3. Okay, that doesn't look that different. What would we say? It's a little what we call narrower. It's a little thinner because the coefficient is bigger than 1. So I'm going to do my best again here to make this nice kind of smooth curve. And my curves aren't especially smooth, but I'm doing my best here. So it should look something like that. And we've got y equals 2x squared minus 5x. But again, guys, this whole middle piece here, we're leaning on the calculator to do that. As long as you put the equation in exactly like this, calculator's going to do it right. If you have the parentheses there and you use a negative for the 3 and this is a subtraction sign instead of a negative, your calculator's not going to make any mistakes. It will make mistakes if you don't put parentheses there. So here's your homework, guys. Graph on a separate plane. So I should see two graphs. I should see a graph for number 1, right? You don't have to, actually, I don't like the idea of boxing around the graph, to be honest with you. So you're going to make your graph. 10 by 10 would be better. My graph I have here is 7 by 7, which is fine, but 10 by 10 would really be better. So you're going to put your number 1. You're going to have your table and your graph. You're going to do your number 2. you're going to have your table and your graph, right? Any questions? And I anticipate maybe there's going to be some questions because it's a tough lesson. All right, again, we're going to really lean on the calculators, but it's not easy. Questions, comments, concerns, as always, guys, upload your homework, post a comment in Google Classroom, and I'll get back to you as soon as I can.